Okay, I think we're going. Hey everybody, hope you had a good weekend. Um, we are in day 19 of what NTI. How could I forget? It's all I've been hearing all week or all these past couple months. Um, so it's Monday. Monday means we got some notes. So we're gonna put out a couple videos, take some notes, maybe learn a couple things, hopefully, and then we'll have some practice tomorrow. And guys, I've been having Google Meets. You are going to get graded for this stuff. So just because we have not been in school does not mean that we're not taking grades and we're not looking at who's doing what. So really, we need to make sure that we're being caught up, okay? That's all I want to say about that here, because I have very limited video time. So for this video, I want to get through the bell ringer and some notes. So the bell ringer for day 19, titled Property of Tangents. The bell ringer says, how many ways can a straight line intersect the circle? So we have this circle here. How many ways can I draw a straight line, and how many different intersections can I have? So first is, well, I'm going to draw a straight line. I can draw a straight line above the circle. That would be one. That has no intersection points. I could draw. So if this is a Fortnite circle, like in the storm, here's the path of the bus. So the path of the bus intersects the circle at two places. So here's one, here's the second possible line we could draw. The third way we could intersect the circle is if this line just happens to pass through and its position is to where it only, so a circle is always changing its position. Like there's never a straight line anywhere on a circle. This is called a tangent line, and a tangent line is a straight line that just so happens to intersect a single point of that circle. It looks like it intersects at a few different points, but just a tangent line is a line that intersects the circle at one point. So you can draw this line, this line. This is called a secant because it's got two, and then a tangent line. So if you're taking notes, I guess to submit this, because you can't really draw on a computer, how many ways can a straight line intersect the circle? Well, that's three. There are three different ways. None at all, just once, or twice. You can't draw, can you draw a straight line that intersects a circle three times? And the answer is no, you can't. Okay, so for the notes portion, we have a few definitions. First, we have tangent line, and I kind of talked about that a little bit up here. A tangent line is just a line that touches a circle at exactly one point. That's what we've got right there. It intersects here. I'll call this point P. Or actually, I'll call it point T. I'll call this point T for tangent. So line 3 is my tangent line, and it intersects right there at that point T. That point T has a name too. So the line is called the tangent line. There's also this thing called the point of tangency. The point of tangency is the point where a tangent line touches the circle. That's this point T. So the line is the tangent line. Where it actually brushes up with the circle at that one point T, that's called the point of tangency. And then on your notes, I didn't write it out here because, you have it on your notes completely filled in for you, but below here it was Pythagorean's theorem. And right, so Pythagorean's theorem is you have a right triangle. Remember, the notes say it has to be a right triangle. So we have a 90-degree angle here, so we can use Pythagorean's theorem to find C, the hypotenuse. That's A and B. Which is, remember, A squared plus B squared equals C squared. We've done some practice with this. Pythagorean's theorem only works for right triangles. So if I have some triangle like this, you can kind of tell there's no right angle. There's no, like, the corner of a room is a right angle. You don't see any right angles here. So you cannot use Pythagorean's theorem here. That's what that one bullet point that I didn't write here is supposed to remind you. Okay, and then lastly, there's a fill in the blank section with A, B, C, and D. When the radius, so the first blank A is radius, when the radius of a circle intersects, you know what, because before we get into this, let me just drop a quick reminder, because I didn't do this. I know that sometimes people might not remember definitions all that well. So if this is a circle, just remember, there's the center of my circle. The radius is the distance from the center of the circle to any edge. So that's a radius. That's a radius. That's a radius. The center of the circle to an edge of the circle is the radius. And you might remember the full distance is the diameter, but that's not important right now. Okay, so when the radius of a circle intersects a tangent line, and we just went over what a tangent line was, when the radius of a circle intersects a tangent line at the point of tangency, the angle formed is always a, sorry, the cat is scratching at the door. Let me go, stop. God, that cat drives me crazy. She either wants in the room or she wants out of the room. She's never happy. She's always wanting something that she doesn't have. So the radius of the circle intersects a tangent line at the point of tangency. The angle formed is always a right angle. This means that tangent lines and radii, so this is just plural for radius, so a tangent line and a radius are always perpendicular. So I'm going to try to just to finish out this video real quick. All that last part said, and it was important, was if you have a radius, just like that, so there's a radius, where the radius intersects the point of tangency, so that means if we have a tangent line going across kind of like this, right, so here's my tangent line and it's touching the circle at one point. Well, at the point of tangency, T, where this radius intersects this, it's not going to be perfect right here because this is not a perfect circle, but in theory, this is supposed to be a right angle, always. Does not matter how, does not matter where you draw the, that's kind of blurry. It doesn't matter where you draw the radius, the tangent line is always going to be perpendicular. Sorry, yeah. The tangent line is always going to be perpendicular to the radius at that point of tangency right there.